All right, so to start filling out our table, we're going to look at 60 degrees. What are the values? Let's start with cosine. What's the cosine of 60 degrees on your unit circle? 1/2?
Yeah.
Okay, so cosine of 60 equals 1/2. Now we want cosine squared, so we're going to square it. If we square 1/2, what are we going to get? 1/4. So let's put that in. So we get 1/4. What is your sine value at 60 degrees? Square root of 2 over? Square root of 3 over 2. Okay, let's square that. Square root of 3 over 2 squared. Square root of 3 squared would be square root of 3. What did I say? Squaring square root of 3 would give us 3. Okay, and then squaring 2 would be, again, 2 squared is 4. Okay, all right? Let's do the 225. Cosine of 225. Negative square root of 2 over 2. Let's square that guy. All right, square root of 2 squared? 2. And then the negative times the negative would make it positive. Okay, and 2 squared is 4. 2/4 would reduce to 1/2. Okay, let's put that in. What's our value of sine at 225? It's the same, right? So we would get the same, 1/2. Very good. Negative 90. Negative 90. So now we're going to come this direction. So we're going to be down here. What's your cosine of negative 90? What's cosine down here? 0. And if we squared 0, we would get 0. Okay, what's sine down here at negative 90? Negative 1. And if we squared that, we would get 1. Let's go one more. Let's go to pi. Let's go to pi. So what's your cosine at pi? Negative 1. And if we squared that, we would get... And what's your sine at pi?
0.
And if we squared that, we would get... Whoops, and I made a mistake over here. Let me correct that. All right, now we're going to go back and we're going to add these up. So I'm going to put in a summation line right here. And we're going to add going down like this. Okay, starting here. What's my 1/4 plus my 3/4? 1. What's my 1/2 plus my 1/2? What's my 0 plus 1? And then what's my 1 plus 0? What do you think these all would equal? Yeah, those would also all equal 1. So you see the pattern? So in every case, what did we do? We added the cosine squared theta and the sine squared theta, and every single time we did that, we got a 1. Okay? So our sine squared theta plus our cosine squared theta equals 1. Okay? This is one of your 3 Pythagorean identities. Here's the first one. Right there. Well, how does that work? How does that work? Why does that have anything to do with Pythagorean theorem? Let's come over to our unit circle. Let's come over to our unit circle real quick, okay? What is the value of, if I use my x and y, and I wanted to set this up? My sides, what are my sides here? I have x and I have y. So if I had x squared plus y squared, that would equal my radius. My radius in the unit circle is what? 1. So my x squared plus y squared equals 1, right? Because of our unit circle having that radius of 1. Well, what's my x? My x is really what? Cosine. And my y is really what? Sine. Okay, so that's where we get our Pythagorean identity. Okay? Any questions on that? Any questions on that? Okay? Now, remember I told you that we were going to manipulate our equations using our identities to help us simplify these down? Did I tell you that? Okay, so we're going to start doing that. All right, we're going to start with our Pythagorean identity. Okay, so we're going to start with our sine squared theta plus our cosine squared theta equal to 1. I want you to do it up here with me. I want y'all to write it down and do it up here with me. Okay, so what we want to do now is we're going to look at these and we're going to write, this first one we're going to write an identity that relates to the tangent and the secant function. That relates to the tangent and the secant function. All right, you have to think about this. Okay, tangent, tangent, tangent. What is another way that I can write tangent? What's another way to write tangent? Y over x. Take the y over x and put in. So it'd be sine over cosine. All right. Okay. I do see a sine up there. I need sine over cosine. Right? Okay. I'm going to manipulate this. To get sine over cosine, that means I would have to divide this whole thing by cosine. So we're going to do that. That's exactly what we're going to do. Okay, so I'm just going to go through and I'm going to divide everything. Since this is sine squared and cosine squared, I'm going to divide by cosine squared. I can do that, right, as long as I do it to both sides. So I'm going to do it to both sides. So I'm going to do it to the left-hand side here. Divide that one. Then I'm going to come over to the right-hand side. I have to keep my scale balanced here. So I'm going to do the same thing. Okay, so what did we do? Let's just write over here what we did. We divide by cosine squared theta. Okay, when we start doing these identities, you're going to have to start thinking outside the box. You're going to be doing some really weird stuff, and it's going to feel really weird. But that's what it's going to take to figure these things out. Okay? And sometimes we'll have to start and throw it out and start all over again if we don't get what we want. Okay, so you just told me that the other way we could write tangent was sine over cosine, right? So can I rewrite sine squared theta over cosine squared theta in tangent? Yes, I can. So now that's going to be, I'm going to replace that with my tangent. So that's going to be tangent what? Squared theta. Plus, cosine squared theta divided by cosine squared theta would give me 1. So plus 1 equals, what do I have on that right-hand side? I have 1 over cosine squared theta. What's that look like? Secant. So I'm going to rewrite it as secant. Okay. What did I do? I took this and I rewrote this in terms of tangent and secant. So here is my second Pythagorean identity. This is number 2. Okay. And our last one, what are we missing? We've done sine, cosine, tangent, and secant. What do we need now? What's missing? We need cotangent and cosecant. Okay. So we're going to start all over again with our sine squared theta plus cosine squared theta equal to 1. And this time we need to bring in our cotangent and cosecant. Okay, let's start with cotangent. What's another way to write cotangent? Cosine over sine. Okay, cosine over sine. Okay, I see my cosine, but what I need below it is the sine. So this time we're going to manipulate this by dividing by a what? Sine. Okay, so we're going to divide this thing by sine. And we're going to do sine squared because that's what we have. All right, so let's do that. Oh, yeah, thank you. Okay, a sine squared theta divided by a sine squared theta would equal what? 1. Those would cancel and they would go to 1. Plus, okay, cosine divided by sine, again, that is our cotangent. That's your quotient reciprocal working, right? So this we would change to cotangent squared theta equals 1 over sine squared theta. The reciprocal of that is cosecant. So we would do cosecant squared theta. Okay? And that, bringing in those last two, that is your third Pythagorean identity. Okay? So you've already started manipulating these. We manipulated these by using, what did I say we were going to talk about today? The reciprocal identities and the quotient identities. So we have used those to rewrite our Pythagorean identities in 3 different ways to bring in all 6 of our identities, or functions, sorry. Okay, so I have a sine theta times a cotangent theta times a secant theta. Blah. Okay, so I want to rewrite this whole thing in terms of sine and cosine. Okay, so we're going to rewrite it in terms of sine and cosine. So what would that leave me with? Well, sine I can't do anything with. So I'm just going to rewrite that as sine theta. I am going to put it over 1. Times, okay, cotangent would be what? What's cotangent? Cotangent.
Oh,
Cosine over sine times what's secant? 1 over cosine. Okay? What can we do? What can we cancel? Yes. The signs can cancel. Remember they cancel, they go to 1. Can we cancel anything else? Can we cancel anything else? Cosine, they will go to 1. So what do we have left? 1 over 1. So all that simplified down to what? 1. Okay? So when we rewrite these, we simplify them. In this case, this whole thing was nothing more than a value of 1. Any questions on that? Okay, let's look at one more here. Okay, write this one down. We're going to simplify tangent squared theta minus a secant squared theta plus 1. We're going to simplify that thing down. All right, you have your summary right in front of you. You have your summary in front of you. What did we just finish working on? Okay, and what kind of identities did we just work on? Pythagorean. Okay. Why am I referring to the Pythagorean theory? Identity. Identity. What am I focusing on here? I'm focusing on, I've got some squares here.
Oh, just kidding. The square.
Okay? So I'm thinking Pythagorean identities. Do you see a Pythagorean identity somewhere embedded in here?
Yeah.
What do you see? If we rewrote this, how could I rewrite this and grab one of those identities? That tangent squared theta, what is it? Tangent squared theta minus
Plus 1.
yes, plus 1. So I'm going to rewrite. Okay, so I'm going to do tangent squared theta plus 1 minus my secant squared theta. So I'm just going to rewrite it. Did I get that correct? All right, so I know then that the tangent squared theta plus 1 actually equals what? And look at your identity. What does tangent squared theta plus 1 equal? It equals secant squared. Right, you see that? Look at your identity. All of this equals a secant squared. So you're just going to replace it with the secant squared. Okay? So we're doing a lot of substituting in, aren't we? We're doing a lot of substituting in, or exchanging. minus the secant squared theta that was still there. We didn't change it. Now I have a secant squared theta minus a secant squared theta. What would that equal? That would equal 0. Okay? So we started with tangent squared theta plus 1 minus a secant squared theta. Well, we simplified that thing down by using this time we used our Pythagorean identity, one of them anyway, and we actually found that what we had was a value of 0. Okay? Any questions on that one? I think we'll go ahead and stop there today.